And now let's solve one more question on testing the continuity of a function. And the question is, find all points of discontinuity of the function f where the function f of x is given by f of x is equal to sin x upon x, where x is less than 0, and f of x is equal to x plus 1, where x is greater than or equal to 0. And now from the definition of given function f of x, the value of f of x is different when x is less than 0 and for x greater than or equal to 0. So in order to check the continuity of this function f of x, we shall have to check the continuity of this function f of x for three different cases. And the first case is when x is less than 0, and in the second case when x is greater than 0, and for the third case when x is equal to 0. So let's check the continuity of this function for x less than 0. Now if x is less than 0, then f of x is equal to sin x upon x. And in the previous episodes, you have already learned that the sine function or f of x equal to sin x is a continuous function, and similarly the function x or f of x is equal to x is also a continuous function. So for x less than 0, f of x is equal to sin x upon x, where both sin x and x are continuous function. And as per the properties of continuous function, which we learned in the previous episodes, the quotient of two continuous function is also a continuous function. So that means the function f of x defined by sin x upon x, where x is less than 0, is a continuous function. And now let's check the continuity of the given function for the second case. And in the second case, x is greater than 0. And as per the definition of the given function, if x is greater than 0, then in that case, f of x is equal to x plus 1. And the given function f of x equal to x plus 1 will be continuous if and only it is continuous for all the points in its domain. And now let C be any point where C is greater than 0. And now as per the definition of continuity, the given function f of x will be continuous at point C if and only the limit of the given function f of x when x approaches C is equal to the value of the given function at point C or f of C. Or in other words, if and only limit x approaches C, f of x is equal to f of C. And what's the value of f of C? Now f of C is equal to C plus 1. And now let's calculate the limit of the given function at when x approaches C. Now limit x approaches C, f of x is equal to limit x approaches C, x plus 1, and which is equal to C plus 1. So the limit of the given function when x approaches C is equal to C plus 1, and also the value of the given function at the point C is also equal to C plus 1. So that means the given function is continuous at the point x equal to C, where C is greater than 0. And now let's check the continuity of the given function at the third and the final case. And here x is equal to 0. And again, it will be continuous at the point x equal to 0 if and only its limit at the point x equal to 0 is equal to the value of the given function at the point x equal to 0 or f of 0. Or in other words, if and only limit x approaches 0, f of x is equal to f of 0. Now the value of the given function is different depending upon whether x is less than 0 or when x is greater than 0. So in this case, we shall have to calculate both its left hand limit and the right hand limit. So let's first calculate its left hand limit. Now limit x approaches 0 from the left hand side, f of x is equal to, now when x is less than 0, then f of x is equal to sin x upon x. So this limit can be also written as limit x approaches 0 from the left hand side sin x upon x, and from the definition of limit x approaches 0, sin x upon x is equal to 1. So that means the left hand limit is equal to 1. And now let's find out its right hand limit. Now limit x approaches 0 from the right hand side, f of x is equal to, when x is greater than 0, then in that case f of x is equal to x plus 1. So the right hand limit can be also written as limit x approaches 0 from the right hand side x plus 1, and which is equal to 0 plus 1 or 1. So that means its left hand limit as well as right hand limit are both equal to 1. And now let's calculate the value of the given function at the point x equal to 0 or f of 0. And as per the definition of the given function, if x is equal to 0, then f of x is equal to x plus 1. So f of 0 is equal to 0 plus 1, or it is equal to 1. So when x is equal to 0, then in that case its left hand limit, right hand limit, as well as the value of the given function at the point x equal to 0, f of 0, are all equal to 1. And as per the properties of continuity, this is the required condition for a function to be continuous. So that means the given function f of x is continuous at x equal to 0. So we have proved that for all the three different cases for the values of x, the given function f of x is a continuous function. And that means the given function f of x defined by f of x is equal to sin x upon x, where x is less than 0, and f of x is equal to x plus 1, where x is greater than or equal to 0, is a continuous function for all values of x. And that means there is no point of discontinuity for the given function f of x. Now let's solve one more question. Find the value of k for which the function f defined by f of x is equal to sin 3x upon x, where x is not equal to 0, and f of x is equal to half k, where x is equal to 0, is continuous at x equal to 0. Now as per the definition of continuous function, A function is continuous at a point if and only the limit of the given function at that point is equal to the value of the given function at that point, or in other words, limit x approaches c is equal to f of c. So the given function will be continuous at x equal to 0 if and only limit x approaches 0, f of x is equal to f of 0. And here what's the value of f of 0? Now as per the definition of the given function, f of 0 is equal to half k. And now let's calculate its limit at x equal to 0. Now limit x approaches 0, f of x, or the limit x approaches 0 sine 3x upon x is equal to, now to calculate this limit, we shall multiply both numerator and the denominator by 3. So now this limit becomes 3 into limit x approaches 0 sine of 3x upon 3x. And as per the properties of limits, limit x approaches 0 sine x upon x is equal to 1. That means now this limit finally becomes 3 into 1 or 3. So for now this function to be continuous, the limit of the function must be equal to the value of the function at given point. So that means, and the limit of the given function is 3 and the value of the given function is half k. So that means here half k is equal to 3, or k is equal to 3 into 2 or 6. So that means the value of k for which the given function f of x is continuous at x equal to 0 is k equal to 6.